Good afternoon and welcome to a SciEM webinar on lighting design and avoidance of impact to bats. This webinar will be presented by Bonnie Brooks. And before I hand over to her, and whilst I'm waiting for everybody to join the webinar, I'd just like to talk about our upcoming conferences. So we have our Irish conference coming up next week on wading into water, the assessment and management of our aquatic environment, and tickets for that conference are still available. We also have our spring conference on biodiversity net gain from policy to practice, a transformative tool for tackling biodiversity loss. And tickets are available for this conference on the training and events area of our website. We also have some upcoming training that you might be interested in. And again, these courses can also be found on the training and events area, along with our full programme. Lastly, an upcoming SciEM webinar that you might be interested in on using bioacoustics for field survey. This webinar will be taking place on the Friday the 10th of May at 12:30. And again, tickets are available on the training and events area of our website. Now, before I hand over to Bonnie, I'd just like to mention that there will be a Q&A session at the end of the webinar. You feel free, though, to send in questions throughout. They just won't be answered until the end. The way to do this is just by clicking on the Q&A icon, which is on the top of your screen. If you click on that, type in your question and simply press send. And yeah, we'll do a session at the end. Okay, without further ado, I will now pass over to Bonnie. Thank you, Bonnie.
Thanks very much. I'll just share my screen. There we go. Okay, hi everyone. Thanks very much for logging in today. I'm a little bit daunted by how many of you there are, but I hope that this session will be useful to you. So I'm going to talk today about the avoiding impacts onto bats. So firstly, I'd just like to introduce myself briefly. I'm a lighting consultant. My background is actually electrical engineering. I'm a chartered electrical engineer and have become a specialist in lighting design. I have over 14 years experience in the industry. I'm a director at Illume Design, and we undertake interior lighting design, exterior, street lighting and day lighting, and we specialise in lighting impact assessments. Not only am I interested in the effects on wildlife and the environment, but also on the effects on human health and well-being, as these sometimes conflict with each other or need to be balanced. I've also been involved in chairing an update to the undertaking environmental lighting impact assessments, and also been involved in reviewing the bats and lighting guidance that's been released recently. I'm actively involved in the industry as a regional representative of the Society of Light and Lighting in the Southwest, and also have spoken at various symposiums. So today I'm going to run through initially the latest guidance and updates that have come out, then talk briefly about the lighting impact assessment process, and then talking in more detail about baseline surveys and proposing a suitable scheme and how we can think about reducing the impact on bats in this process. So the most recent guidance that's been released is the bats and lighting guidance. This was from the BCT and also in conjunction with the ILP, Institution of Lighting Professionals, and it was released in September last year. Quite an important quote from Jo regarding the guidance. So she highlighted that we continue to learn more about how lighting impacts on bats and wildlife, and that this guidance is to raise awareness of the negative impacts and how we can avoid these. It also placed emphasis on the importance of interdisciplinary working between ecologists and lighting engineers, and also landscape architects and professionals also play an important role in this collaboration process. The guidance can be downloaded from the ILP's website, and there's also links on our website as well. So this guidance is really broken down into 3 sections, one on bats, and the next on artificial lighting, and then on mitigation. And there's also a glossary of terms, which is quite useful so that we can all start to talk in the same language between different professions when we talk about lighting. One thing to note on this is a correction. On page 21, depending on when you download the guidance, the maintenance factor should say 1 and not 0, and I'll explain a little bit more about this later on. Another guidance that I'm working on at the moment, which is hopefully going to be released in early this year. This is more aimed at lighting professionals, but there will be a summary section that's aimed at anybody involved in the lighting impact assessment process. So this is going to place a lot of emphasis on this common language, making sure that not only, because between professions we use different terminology, but also to make it more complicated, lighting professionals often use different terminology. So we're trying to make that a common language. And also emphasizing, as I mentioned, about collaboration between particularly landscape architects, lighting designers and ecologists. But also between architects in order to find the best solution, because if we look at this from the outset, we can often have a more positive effect. It's looking to introduce a consistent approach to reports so that they're easier for everyone to read, and talk about methods for assessing impacts on bats, such as the vertical calculation planes and key plans, so providing this information in the way that's going to be the easiest for people to understand and interpret. Another guidance that I was involved in was for the Bath Enterprise Zone, and there are some common themes between this guidance and the recent BCT guidance, so it's quite a useful one to actually have a look at, and I'll highlight a little bit more about that later. So the lighting impact assessment process, a brief overview. So not only will we consider sensitive receptors from the outset, which could be bats, but also other types of wildlife, such as barn owls, badgers, birds. Also, we need to consider obtrusive light and light pollution. So this is the impact on the dark night sky, and also on humans that may be living close to an area that's being lit, such as light going into people's bedroom windows. Then also another aspect of a lighting impact assessment is to consider the visual impact, which is often done in conjunction with the landscape professionals. So this is an example from a project quite a few years ago now, but it's one that I like to show because it illustrates that with lighting, we can potentially make a difference to improve an existing scenario. This was a site in Baltic Wharf, Totnes, which is in South Devon. And there was a regional bat flight path that was adjacent to this site. It was due to be proposed to be developed into residential development, but was currently being used as a storage area. So the photo at the bottom here shows the view from a quarter of a mile away, actually along this dark bat flight corridor that was being used by greater and lesser horseshoe bats. And as you can see, the lights are really bright and obtrusive. There's a lot of glare, luminance levels that can be seen from there. Some people may say this was security lighting, but I'd have to disagree with this, because these were 3 floodlights mounted on columns that are pretty much facing directly into the sky, lighting an area at night that isn't even being used. So it was really over the top. Plus we have a mixture of sources, so sodium that has less impact on bats, but also metal halide, which is not good when we consider the impacts on bats. So with this site, even though we were developing it and putting in probably more lighting in terms of numbers, it would actually be a much more sensitive scheme with downward directional lighting, very minimal glare, so a better scenario in the end. So looking at the lighting impact assessment process, it would typically consist of a baseline survey. This involves desktop research, but also visiting site, taking daytime, nighttime photographs, recording light level measurements, and looking at the existing lighting on the site. Then we move into the design and assessment section, which I'm going to talk about more in a minute, and then mitigation further on from that, if required. So, baseline survey. These are not always required. It may be completed as part of a full assessment to accompany an EIA, ES statement. But also in some instances with planning applications, it's quite useful to demonstrate the existing levels of lighting on site, particularly where there are lit areas where sensitive receptors have been identified. So an example of this is the holiday park shown. The bat flight path that was existing was actually flying along these vegetation that's shown here. And there was lighting that was directed directly onto this dark corridor. So we were able to understand the light levels that were on the site at the time, and also show that the vegetation itself was really serving a good purpose at blocking and screening the light, as there was very low levels to zero in the bat flight path behind the vegetation. But by doing this, we could then make sure that the new installation was even a reduction over the existing scenario by reducing lighting that was facing this dark zone. And also some examples shown from the Bath Enterprise Zone, where we undertook baseline surveys to understand the light levels, ambient light levels along the River Avon. And we also picked up on our survey some lighting that probably contravened planning, where floodlights had been installed directly onto this towpath. We could understand also internal light spill and how that was affecting certain areas of the dark zone. So a baseline, a typical report would include information on the sensitive receptors, site location, details of legislation and planning, policy guidance, particularly relating to the site. And we would use this to understand the environmental zone for that site. So when I talk about environmental zones, these are environmental lighting zones. So they are broadly classified. So we have going from, there's 5 zones, and it goes from a E0, which is protected, so like a dark sky park, through to E4, which is urban, so a town, city centre. But what we've got now in the latest guidance from the BCT is separate identification for existing or proposed dark zones for use of wildlife such as bats. And these are zoned from A to D. So what you could have is you could have a suburban location which would fall in a lighting zone E3, but within that we might have zones that are required for bats, such as a hedgerow that might be zone A to be the dark zone, and then a buffer zone within that itself. So it's just introducing the kind of 2 zoning systems alongside each other. So this is an example of a baseline survey drawing and what you might expect to have produced. So this is for a site that was for a small housing development that was adjacent to a bat roost and cave. So there's a vegetation bund here that needed to be protected and kept dark. And also here was the caves towards the back of the site. And we also had existing street lighting along the road adjacent to the site, which we were also looking at reducing the impact so that bats could cross from this cave out towards the east. Measurements were taken at ground level, measurements of illuminance, and also in the 4 compass directions, so vertical illuminance at 1.5 meters in height, so that we can understand levels of light where the bats were flying in the existing scenario. This is an example of a baseline survey for a much larger scheme. So here the ecological locations are shown in blue. So these would be agreed with the ecologists prior to the survey taking place to make sure we capture all of the important locations. And also there's green locations which were for landscape and visual, and then orange locations which are used to understand what was going on in those areas in terms of lighting. So there was a park and ride that was highly lit, a playing field, and also an industrial area. So it was to give context to the rest of the assessment. So the next stage then with a lighting impact assessment is starting to think about proposing a suitable scheme. And this is where we can make the most difference really to reducing impacts on bats. So it needs to be thought of at this stage, and it's what we call primary mitigation as part of the design itself. But before I go into that in too much detail, I just want to talk a little bit about lighting terminology. So we have a luminaire, or as it's shown here as a candle. There's luminous flux, which is in lumens, which comes off of the light source. and then this is directed towards the surface. Often we talk about the ground. And what we have here is illuminance falling onto a surface. This is what is measured in lux, and this is what you have when you have a lux contour plan. It's levels of illuminance, so light falling onto the surface, that is being shown on the plan. But another aspect that's quite important is luminance. So this is actually the light that is received by our eye. So if we look at a brightly lit surface, or we look at the light source itself, the light received by our eye is what is called luminance. It's measured in candelas per meter squared. And it's easiest to think of as brightness. It's not technically quite the same thing, but it's the easiest way to think of it. So brightness and actually the light falling onto the surface are two different things. They are related, but they're not the same. So one instance to think about to understand this a little bit better is I've often been to site and I'll be looking at a hedgerow that's a sensitive feature, and I'll be asked to take measurements at the hedgerow because it's been described as very brightly lit. There's lots of bright sources close to the hedgerow and it's brightly lit. But when I actually get to site, the scenario might be a little bit different. Actually, there may be a bollard that's quite close by. It's very visible from the hedgerow and looks like a very bright source because it's directed in all directions and you can see that lamp and it looks very bright. But actually, when I measure illuminance at that point, I may get 0 or close to 0 because of the aspect of this being two different things. The light falling onto that surface at that point is actually quite dark, but you can see the lit source in the view. And I think this is something that's highlighted by the new guidance, that those two aspects need to be thought about. And by considering shielding and downward directional lighting, which we talk about later, we can also address the luminance aspect. So when we think about lighting measurements, first of all, it's important to understand that it is a 2D measurement that's taken. It's the easiest way, I think, to explain it. The light meter is pointed in one direction and you get a measurement for that direction. So if it's placed on the ground, facing upwards, you're getting a measurement falling onto the ground. And then similarly, that's why we do vertical measurements in several compass directions so that we can understand what's happening at that point, but from all the different directions that light may be hitting that point. And so if you similarly think about calculations, it's a very similar idea as shown in this image. You could basically think of it as, instead of light meters put into a grid, it's actually a grid of calculation points. And these points are joined together to give you the isoline contour plans that you see often for this type of work. And similarly, you could also have a grid of measurements. So when we talk about calculation planes, you're probably all very familiar with lux contour plans, which provide a horizontal calculation plane on the ground, and this captures light hitting the ground. But what the new guidance really places importance on is also considering vertical calculation planes. So thinking about what's happening at the height that bats are flying, which might be sort of 1.5 to 2 meters for greater or lesser horseshoe bats. And so in order to do this, we need to put a calculation plane into the lighting model that captures light hitting this area. So potentially this could be a hedgerow, and we would put vertical calculation planes along there to see what was happening with the light. And that would capture light from any direction. So if you have a bollard light that was directing light at 90 degrees, or also internal light spill from windows, it would capture anything that was hitting the light on that surface. And this is really where sometimes it's asked for horizontal calculation planes, or people may even say vertical, asked for a height. So perhaps sometimes it's asked for a 3 meter height plane to be shown and a lux contour plan to be produced for that. But this is really something we want to be moving away from because it can be very misleading. So if you imagine if I produced a lux contour plan for the ground on this particular site, that would be fine. You'd understand what's going on. But if I then produced one here, it would only be shown for light that hits this surface from above. So any of the light from windows below or from bollards below, or any maybe in-ground mounted lights, nothing would be recorded from that. It would only be light hitting this surface from above. So if you imagine a scenario where a calculation plane might be put at 6 meters above the site, you'd have no light recorded in this scenario, even though there was light in the area, and light may be hitting the bottom of that plane or from a different direction, but it wouldn't be hitting it directly straight down on top. So it's something to understand that really we want to be sticking with the scenario of looking at light spill on the ground from a Lux contour plan, and then vertical calculation planes. And the vertical calculation planes won't be shown on a drawing. You'll actually get information shown in more of a chart format that relays to each of the vertical calculation planes that you have along the features that you've identified. I hope that makes sense. It's kind of a difficult one to explain, but I think it's quite important to highlight that this scenario can be misleading when you get Lux contour plans for varying heights, as it may not capture all of the light that is on that site in that area. So moving on to lighting impact assessment. So as part of a lighting impact assessment, a lighting strategy would be included. So this is usually the proposed lighting section, and that's what I'm going to talk about now in more detail. So from the outset, we want to consider the sensitive receptors. And the best way for us to be able to do this as lighting designers is for a plan to be produced by the ecologist that shows the dark zones or corridors required with the zonation shown. So dark zones with buffer areas so that light can attenuate down. And that way we can understand really clearly where we need to keep dark, and we can understand when we put the ice lines onto the drawing and put the vertical calculation planes in, we can really understand what's going on. And then I'm going to talk about various aspects that make up a scheme now. But a main philosophy that I like to think about is we want to be putting the right amount of light where and when it's needed. So in order to do this, firstly, we have to consider what the area is and how it needs to be lit. What is it going to be used for? Not only thinking about average illuminance for a task and uniformity, but also there's other considerations that affect people's visual comfort and how safe they feel in an area. And this can be to do with glare and contrast in an area from lighting, and also how well people can see each other's faces as they walk towards them at nighttime has a big impact on how people feel safe in an area. So that's kind of the lighting considerations, or some of them. Something that's highlighted in the new guidance is about legal requirements. So there's no legislation requiring an area to be lit, but there are legal implications, or there could be legal implications of not lighting an area. So this needs to be carefully considered with the client and the architect to make sure that a risk assessment is in place for areas that are going to be lit to lower levels to make sure that they're still going to be safe and suitable for use. And this is something, as I said, that you can read about more in the guidance. But something that I wanted to highlight is that we want to avoid developments that are not fit for purpose. We've got a site in Devon where actually no lighting was provided to the house entrances. There's no street lighting, there's no lighting externally at all. And the problem with this is it's really not very practical. It encourages then for poor lighting to be added later. A lot of the houses have added floodlights, perhaps from B&Q, and unsuitable light fittings that they found. And they've been added to the houses because people can't see to get into their doors. So by providing, if we'd have provided in that instance a more suitable solution, a sensitive light fitting that was downward directional of a low output, it would have avoided the poor lighting being added later. Another aspect that also affects light levels is whether the roads within a development are adoptable or private. We have a lot more flexibility with private roads to reduce the levels of lighting, whereas adoptable roads, there are requirements that we have to think about. So again, the reason that highways are lit is because it's seen that the safety and positive benefits outweigh the negative in most scenarios. Another thing to mention on this one is that in previous guidance relating to bats and lighting, low pressure sodium was often recommended as a light source to use, but it's worth knowing now that low pressure sodium doesn't meet the requirements for road lighting because it has poor colour rendering, which means you cannot make out various colours within a scene. and it's now also being phased out. So these type of lamps will not be available in the not too distant future due to the changes with LED and efficiency. Briefly, just to say that there's a lot of different requirements, as I'm sure you're probably aware, for various different installations in order to meet the British standards for various different types of installations. So this is what a lighting designer would use to understand what levels that particular site should be lit to. And as I mentioned, adoptable roads, for example, the local authority will have their own particular requirements and specifications that they'll like to be followed. This will determine levels, classifications of roads, and also they may actually specify the type of optic outputs and also color temperatures, which is something that's obviously highlighted with the new guidance. We want to be using warm white color temperatures, and a couple of councils are now switching over to warm white. So for example, Cornwall Council, their street lighting is now all going to be warm white, and I think in Wales also. So hopefully this will catch on and this will start to be something that's rolled out more nationally. So this slide is just really to help you understand a little bit more about light levels and what we talk about when we consider different levels of illuminance. This is also included in the Batson lighting guidance if you want to refer to it. So when we talk about 0.5 lux, this is typically relates to a clear full moon, those kind of levels, which are normally stated at 0.3, 0.35, and I've measured up to about 1 lux in a full moon. And when we talk about lighting areas externally, typically levels will be between about 5 lux up to 20 lux and maybe 50 for a loading bay. So that's the kind of levels we're talking about. And considering that, comparing to an internal scenario, perhaps at your desk when you're in your office, it would be about 300 to 500 lux. So it gives you an idea of where 0.5 lux sits in our sort of visual everyday capacity. When determining lighting levels for roads, various factors need to be taken into account: types of road, traffic flows, the environmental zone that we talked about previously, and levels of crime. And also what feeds into this idea of the levels that are required is the light source that's being used. And by using a LED light source, we're often able now to actually reduce the light levels down slightly because our eyes are actually adjusted to see this light better. So for example, if we look at a P5 class for a road, which is a typical level that a residential road might be lit to, the levels would be 3 lux average and 0.6 lux minimum. But if we consider using an LED source, we can actually reduce this so that the minimum is 0.4 lux, which can be quite useful if we are trying to design to levels like 0.5 lux, as if we want a crossing point through a road, we can reduce the levels down and use the 0.4 minimum at the point where the road crosses. So try to space the luminaires out to achieve this minimum point, and we can still then achieve a compliant road lighting design. So an important aspect to consider during the lighting design process is choosing the light source. So the light source that you choose will affect color rendering. So this is, for example, how well you can see what color this car is. It's actually blue, but the second photo down shows low pressure sodium, which is what I explained earlier. Because of the color of the light source, you can't see the color of the car. It's very brown and everything appears a very similar color. The light source choice also affects maintenance, energy efficiency, and has impacts on the control strategy that you can use. With LED now, we can have control strategies that are able to dim and switch off instantaneously. So it's a benefit over discharge lamps, where like sodium, and where we couldn't do this because they have a different restrike time of maybe even 10 minutes. So they can't be switched on and off easily. Considering color and spectrum, so things that we already know is that LED lighting is preferable as it has no to low UV component. Blue and green lights have a high impact on bats, and white light should still be avoided if possible. Red, amber and warm lights cause less impact on bats, but birds are shown to be less disturbed by green. So there's a little bit of a conflict there. Philips lighting did actually produce specific luminaires in amber and red and in green, but these were 5 times the normal price, and I think that really this is not the kind of approach that we want to be using. If we're trying to go for right light, right place, then this isn't the right light. I wouldn't want to be walking in this car park, especially the green one at night time. I think it would look quite disturbing. So I think it's much better if we can keep the dark areas dark and the areas that are lit to a lower level, and using the latest guidance where we talk about using warm white color temperatures. So the latest guidance highlights that we want minimal UV, which is achieved by having an LED source, warm white color temperature, which is 3000 K or 2700, ideally 2700, but this is not always available for light fittings. We've had a problem getting down to 3000 K. That's still slightly difficult to get some manufacturers to provide and supply. And 2700, there's only a few manufacturers that supply it at the moment, but I'm sure that will change in time. We also need to ensure that the light sources peak higher than 550 nanometers, which I'll explain a little bit more in the next slide. So a little bit of a recap really about wavelengths, and talking initially about humans and their eyes. So thinking about the electromagnetic spectrum, the visible light spectrum is this area here on that spectrum. And considering this graph, this is the visual efficiency. Basically, the efficiency of your eye is shown by the dotted line. So humans, during the day, this is how their eye effectively sees. We see better in the wavelengths, sort of in the green area. And then if we consider, the thing is, our eyesight changes at nighttime. So the photopic is during the day and scotopic is during the night. So that's why when we have blue or whiter LED lights, they appear to be a lot brighter to us because our eye is more sensitive to those spectrums and sees more effectively in those spectrums. And it's one of the reasons I think that white light was advocated so much in road lighting. Initially, they were using very, very white or cool white temperatures in road lighting. The other reason is that efficiencies in LED is much more efficient in the blue spectrum, because in order to make it, essentially is a blue light. So in order to make it white or warmer, you have to add phosphors to the LED, which decreases its efficiency. So when it was a very big energy drive initially with LED, it was beneficial for lights to be cool white, and we saw some street lighting that went in that was quite blue in its tinge, and it was because it was so efficient. And from our point of view, we would view it to be brighter. But what we know now, with considering the impact on bats, is that we want the peak wavelength to be 550 nanometers or greater. So it's in this yellow, orange, red end of the wavelength spectrum. And it's actually the opposite to how well we see at night. It's not as good for us because that's where we would see best, in this blue to green range. So the graph here on the right shows LED luminaires and their wavelength spectrum. So if we look at 2700 and 3000 Kelvin, which are the warm white, which are recommended, you can see this is the green and red line, and they peak way past the 550 nanometer mark. But if we consider cool white, 4000 or 5000, they peak way before 550 nanometers. So that's what we are talking about and what we're looking for from a light source. And maybe more clearly, you can see it between these two here, which show cool white and warm white. Cool white has a much greater blue wavelengths within the spectrum and its makeup, whereas warm white peaks much later and has a much lower content of the blue wavelength. And just going back to how this affects how we see, with daylight, because of all of the visible spectrum is within that light source, it means color rendering. We see colors perfectly in daylight. Within an incandescent lamp, which was the old kind of lamps that have now been phased out that would typically be used in people's homes, They were a really preferred light source because, again, you could see very well with them because they represented within them all of the wavelengths. But going back to low pressure sodium, which is the very orangey light that we saw a moment ago, the wavelengths are very narrow in that, and that's why we can't see many colours when we look at that light source. This is the information that's included in the guidance, so it goes into a little bit more detail if you want to read up on that some more. So another aspect of the lighting scheme is choosing the luminaire. Mounting types are important. Previously, there was very much a focus on low-level mounting heights, but actually with the new technology in LED, by using higher mounting heights with columns, we can direct the lighting more effectively at the areas we want to light and keep the darker areas dark, so it can be beneficial. We also have much more control now over the luminous intensity of the light sources, with lots of opportunity to use different luminous optics, which I'll show you a bit more in a minute. So in terms of luminaires, low-level lighting, so this is a very typical bollard, which is something that I really don't advocate. It's not accepted in adoptable areas because it's very prone to vandalism. There's an increased cost to purchasing these. You need a lot more to light an area. They have a very poor performance, and they cause a lot of light pollution because light is directed at 90 degrees out from the light source. They're quite glary and bright, as we talked about before. This is the kind of light you'd see on the horizon and would form a barrier, perhaps to bats. They're not suitable for any secured by design approaches, and they don't promote good facial recognition for people using an area. So bearing that in mind, that's the traditional type bollard that I really think is something we want to be trying to avoid. But what we do have now is what's referred to in the guidance as a specialist lighting bollard. So this is much more suitable. It's completely downward directional. The light sources are integrated into the fitting itself, so you can't see them from a distance. They have a very low upward light ratio, so really good in terms of light pollution as well. And they can be supplied in warm white color temperatures, either 3000 or 2700 for a couple of the ones shown here. They are more expensive. A budget cost is around £400 to £600 at the moment, but I'm sure as these start to be used more, the prices will come down. So yeah, talking about optics and how now with LED we have a lot more control over the way we direct the lamp to light the area we're trying to light. We can choose an optic that's suitable for the area we're trying to light. So for example, shown here is just 3, a narrow, medium and wide. If we have, for example, a footpath or a narrow residential road, we can choose the luminaire that's most suitable to light that road and has a narrow distribution. So this is a plan view of the distribution of light from that light source. And whereas typically it was recommended that the light source be placed directly adjacent to the dark zone and that a back shield be added, this often isn't the best solution. With the new optics and the range of products available now, it's actually quite a good idea often to use, if this was the road we were trying to light in blue, if we put the column on the opposite side to the dark zone and use a suitable narrow optic, this line could be cutting off at 0.5 lux or 0.4 lux, and therefore the dark zone would be kept much darker than in the first scenario of putting the light source next to the dark zone. So it's something to bear in mind now that really we have a lot more control over the photometrics of the fittings with LED, a lot more options to light different areas and avoid the light spill. So back shields, this should be a last solution. So we want to use the design element first to design so that we're lighting the right areas and limiting light spill onto dark zones by using the correct fittings. But where back shields are used, it's worth noting that they have quite a small effect. A lot of people think that they're like quite a magical solution. We'll apply a back shield and no light will be going backwards from that light. But that's not actually the case. Often they only reduce light spill by maybe 1 or 2 meters, considering the 0.5 lux line. So they don't have a huge effect. The other problem is that they're not quantifiable. So where I talked about photometric data, that's the data that we use in lighting software to predict the impacts from the light sources. But if you don't have the data for the backshield, we can't model that and show the impact on a lux contour plan. And the same with baffles, cowls and hoods. Really, they should be considered as a last resort. They are difficult to predict as well, the effect from those. And we need to ensure that they're actually fitted as well. So where you are using those kinds of measures, we need to ensure that a post-installation check is done to ensure that they've actually been fitted and are doing the job that they're supposed to do. In terms of controls, we have the typical timers, photocells and PIRs, and also now, as we talked about with LED, there's a lot more option for dimming strategies throughout the night and part night lighting where lights are switched off. This kind of depends on emergence times for bats on a particular site, whether or not it will actually be useful in reducing the impacts. So briefly, I'm going to talk about mitigation. So really, the mitigation, as I said, should be built in during the design process as primary mitigation. And the mitigation process is talked about in the guidance with a useful process chart that goes through what needs to be done, identifying key habitats, and right through to demonstrating compliance. It also talks about the different zones that we spoke about at the beginning and gives information on what these zones might be. And within the Bath Enterprise Zone guidance, this shows how you may apply levels of illuminance to these various zones to allow a transition down from your very dark area to the area where the development zone is within. Considering mitigation options, one of the easiest ones to reduce the impacts considerably is considering site configuration. So if we are involved at an early enough stage, we can consider site layout. Building positions can be planned to minimize the impact. We often are brought in too late, but this is something that we're trying to promote with lots of the early collaboration and early involvement. I've looked at lots of different sites. For example, 24-hour sites are a good example of this. Energy from waste, they may have visitor areas and also 24-hour use areas. But if you have an input at the beginning of the when the site is being planned, we can talk about where there are any sensitive areas and how these timings and the way the site will be used can be factored in to reduce the impacts. So I'm not going to run through all of these. This is basically what we've just talked about. It's just a recap of mitigation measures for external lighting. So the main things are LED, no upward light, so downward directional luminaires, using a warm white color temperature that has a peak of less than 550 nanometers, and no UV. Considering column height, so low level is not always the best option. But if you do want to go low level, then considering a specialist bollard that is downward directional. And also controls. And it may be that it comes to a point of looking at lower levels of lighting within that area. But this would be subject to, as I mentioned, risk assessment and considering the safety on the site. Just to touch on internal lighting. In order to reduce the impacts from internal lighting, we can look at revising window locations and sizes, and a big one is recessed lighting. So considering recessed lighting instead of pendants and moving these away, setting them back within the room can reduce the impacts quite significantly. There's also consideration to blinds, but unless they're automatic and in a type of installation such as commercial, where it can be ensured that this will be continued to be used, they're normally not really accepted as a mitigation measure. Glazing treatments is another option, so reducing the window transmittance by specifying a different glass, and this should be built into the glass itself rather than using window films, as they're also not very robust. The guidance also talks quite a bit about natural and artificial screening, topography of the land, as these can all give benefit in reducing the impact. But what it does state in the guidance is that planting shouldn't be used as the sole means of attenuating light. And that's something to bear in mind when you consider lighting and light modelling, is that we can't actually model trees and vegetation accurately. We can only model solid features such as banks or fencing, those kinds of things. And two other quick things to mention is, as I said, maintenance factor. So when you are looking for a lighting impact assessment, in order to assess the ecology impacts, you want the drawings to be based on a maintenance factor of 1. Typically, design drawings would be based on 0.7 to 0.8, as they take into account the degradation of lamps and luminaires and dirt accumulation over time, whereas what you want to be assessing it on is the worst case scenario at day 1. So that's why a maintenance factor of 1 should be used in order for the assessments to be done. And also, as we mentioned, post-installation checks. I think this is becoming more of a requirement now, and I'm starting to see it built into planning conditions that post-installation surveys and measurements are conducted. Okay, so I've got a few more minutes to just run through some project examples. So this is an example of a lighting impact assessment for a small housing development. It's actually the one that I showed you the image for the baseline survey earlier. So where we have this vegetation and bund, and this was the dark area that needed to be kept dark. So this is what we call a key plan. It shows the vertical calculation planes in blue that were placed along the edge of the dark zone, so that you can understand not only light spill on the ground, but also in the vertical sense along this dark zone. We also show on here what's been modelled. So in this instance, the internal lighting of this plot was modelled and the external lighting as shown. And also we ended up with mitigation of a fence. So that's also shown on this drawing, its location and its height. The vertical calculation planes can be seen in this 3D view in yellow. So they sit within the model in this way. So this was the dark zone plan that was produced. This was actually requested by the council for this project. So we have the dark zone as explained here, and we also have a zone of no artificial lighting. So no artificial lighting can be installed within this area of the back garden for this property in order to protect the dark zone. So this shows the isoline contours in 3D. So we would normally provide this as an image and then also provide the traditional Lux contour plans as well to scale. And you can see from this, this is prior to mitigation because we had to reduce the external lighting. And this is after mitigation here. So anything that is above, shown in grey is less than 0.5 lux, and anything above 0.5 lux is shown in purple or coloured. We had to remove some of the external lighting and add a fence, as I mentioned, and additional planting was added in this instance. The vertical calculation plane results would have been produced in this way so that you have the reference number, where it is, but also you have the key plan, which is even clearer, and the results on that plane. So you can see how the light is distributed within that vertical plane. This would be ground up to 3 meters in height, and the length that's shown on the key plan, so it might be, say, 10 meters long. So you could see if a bat was flying at 1.5 meters, the light levels that would be predicted at that point. This is just an example to show a larger development where we can show Devon Bank's topography of the site and fencing within the model itself. An example of the difference between recessed and pendant lighting is quite useful to actually see how much of a reduction you can achieve. So the yellow line here is the light spill from a group of domestic dwellings with pendant lighting, which is this type of lighting here, suspended basically from the ceiling, compared to recessed lighting, so downlights within the properties. Again, on this side, you can see that the yellow 0.5 lux line is significantly reduced, and it can bring it down from about 30 meters spill to about 8 to 10 meters spill, depending on the scenario and the glazing involved. This is an example of street lighting strategy that was provided with the dark zone shown. So in order to, initially we produced a compliant design to the council's requirements that was fully compliant, and then we looked at options for limiting the impact. And so we did this by reducing the output of the luminaires that were adjacent to the dark zones. So where we have these at the end of the turning circle, these two luminaires were reduced in output to reduce the impact on these dark zones, which were overlaid and shown on our CAD plan. So you can see more clearly at the crossing point. As I mentioned before, we can move the lights to make them as far away as from each other on the crossing point itself, so the minimum level of lux is within that crossing point. So the darkest point is there, and we can design around that. And I think, yeah, some of these luminaires were actually also dimmed, or their output was actually limited in order to achieve a lower level of lighting at that point. An example of post-monitoring, so sometimes these will be used to prove that the lighting levels are as predicted, or also they're used sometimes in retrospective planning applications to prove whether the levels are acceptable or not. This particular one, the client had planning permission to put the lodges in facing the opposite direction, and they got installed the other way around. So we had to go and do checks to make sure that the light spill was acceptable. And we also modelled it in this instance as well. And this shows the baseline survey points where we took our measurements during that post-monitoring. And that's the end. Thank you very much. I'll try and answer some questions now.
Great, thank you so much, Bonnie. Okay. So before we do the Q&A session, you can record this webinar as CPD, and you can log it against the following competencies, which are M2 and A3. So design and preparation of habitat, species management, enhancement plans and projects, and environmental impact assessment. Okay, and there's just a screenshot of how to record that on the CPD tool if you're a SAE member. Okay, we'll go on to the questions now. We've had quite a few come in already. So we've got one from Laura. In the BNES document, there's a short section about impacts of lighting from inside properties. It suggests placing light fittings further back in the room to avoid spill through the windows onto surrounding habitats. Has much research been carried out on using one-way or privacy glass on properties, and is this guidance going to be included in planning policy?
Okay. Oh, where's the question gone? There it is. You just moved it on me. Okay. So firstly, the bit about one-way glass and privacy glass. There hasn't been much research carried out on this as far as I know. But one thing to bear in mind with privacy glass, often that's the type of glass that becomes a translucent kind of white effect when it's switched on. And this can actually gives off light in a lot of instances. So it's not quite as useful as I think possibly people might think it is what I'd say on that one. It's not something I've had a huge amount of involvement in because it's also a very expensive measure. And when I looked into it, I didn't actually think, as I say, it would be useful because I think light actually is emitted by the glass when it turns to this opaque white kind of view. With regards to if this will be included in planning policy for Bain, so Bath Council, I think it probably will, but I don't actually know anything about that, so I wouldn't really want to comment on that.
Great, thank you. Another question, can you recommend an affordable light meter suitable for use at night?
The short answer to that is probably no, because a lot of the cheaper light meters are not very accurate at all. You can use your phone, but I wouldn't even bother because that will be a waste of time. You can buy very cheap meters, but they're often very inaccurate. If you do want to buy a light meter, there's two guidances that are available, one from ILP and also another from Society of Light and Lighting. There's actually a link to those documents on our website if you want to take a look at that.
Great, thank you. And we've had a couple of attendees asking if they can receive a copy of your presentation.
Yeah, I should be able to put together a PDF, but it will just exclude any of the project examples.
Okay, that's great, thank you. Sivi asks, do you have an example of a vertical survey diagram?
Okay, so by a vertical survey diagram, so I guess what you're asking is so as I mentioned, the vertical calculation planes are placed within the site. So you'd have a key plan that would show that. And then the vertical calculation plane results would just be a grid of measurements. So I don't really have an example, but an example was shown in the presentation of that.
Okay, thank you very much. Danny says, although, I'll pop this on your screens. Although there are no legal requirements for lighting, it is my understanding that current regulations for all new residential developments require street lighting on associated access roads, and this often makes it very difficult to propose zero lighting areas. Do you have any advice when there is conflict between the best ecological design and the required lighting to meet building regulations, etc.?
Okay, so there is no legal requirement. It partly depends on the council that you're working with as to how flexible they'll be with lighting of the roads and to whether they can deviate from the British standard. Because as I say, that comes down to risk assessments and whether they're willing to sort of accept that. Most councils are becoming more, they're able to discuss this more and propose a sort of deviation from the standard. Often a good thing to think about when you're looking at this, so is the initial looking at where are your dark zones. So when they are very close to roads or within lit areas, it's initially trying to balance these out and move them to a more suitable location. Private drives within those developments often are on the sort of outskirts, and they can be coordinated so that they're with or next to the adjacent dark zones, and these are often much more acceptable to be kept dark, as it will be under the private developer's control and a management company after that. So you have a bit more flexibility in those areas. So yeah, it's a difficult one. My advice probably is to get the lighting engineer and ecologist to liaise early on to try and resolve those issues.
Great, thank you. Another question from Emily. Do you model light reflection from the ground, for example, from wet road surfaces, impacting on bat flight routes?
Okay, so with this question then, if you consider the horizontal illuminance falling onto the ground, that wouldn't really be it does take into account to some extent reflectance, but not of like wet ground and things like that. So probably no. The vertical calculation planes will take into account reflected light, but again, we don't look at different scenarios for wet roads and dry roads and that kind of thing to that level of detail. And it probably would have a very negligible effect, I would say.
Okay, thank you. Andrew says, although it may be that Lux is low outside the illuminated area, lights are still visible when looking towards them, i.e. when looking across the road at a light or lit area. So although Lux may be low within a dark zone, the presence of lights are still visible from a distance. Does this not deter wildlife regardless of the actual Lux measure?
Yeah, so I think that's one that's maybe not enough research on it yet, but I have seen some research that points towards thinking that that kind of lit or brightness within the view can cause a barrier to bats. And I think that's where the guidance is addressing this, in the sense of considering luminance or brightness from light sources and ensuring they're downward directional. So by having sources that are not visible, you reduce this kind of barrier effect and the brightness aspect. But I think maybe more research is needed on that aspect.
Great, thank you. We've got a couple of similar questions here. So Oliver asks, glazing treatments, where can we get information about different types of glass available? And Drew says, my client tried to find a manufacturer who could supply glass which reduced light pollution from inside. He couldn't find a single supplier. Do you know of any?
Okay, that seems very unusual that that would be the response from them, because all of the major glass providers, such as Pilkington, which I think he listed there, do provide glass of different transmittance. So typical double glazing is 80%, then 60 and 70% are often used for schools, because used for opposite reasons, really, to do with daylighting to reduce the impact, but they work in the same way. Transmittance is prevented in both sort of directions. And you can go down to 50% transmittance. You can go lower, but 50% is where it starts to be noticeable to the kind of occupant, and would start to look like it's been reduced or have some kind of film kind of look to it. So, but yeah, that is available. There's no doubt about that. We've specified it on a project recently in South Devon, and they're going for, I think, 49%. So it is available.
Thank you, Bonnie. Just to say, it's now 1:30. We've still got 24 questions. Would you like to carry on with the Q&A, or would you like the questions to be sent to you for an answer at a later date?
I'm happy to carry on for another 10 minutes if you'd like.
Yeah, that's great. Thank you. Okay, Chris says, why was the value of 0.5 selected?
Okay, I think the answer to this, and maybe don't hold me to it, but I think that there was a particular research paper from Emma Stone that mentioned 0.49 lux, I want to say, was the number. And from then on, 0.5 lux was used for certain bat species. But really, that's not my area of expertise. So that's what I think the answer to that question is.
Great, thank you. Harry says, should we be requesting ISO-Lux plans to be prepared using specific software packages, or are they all similarly effective?
Okay, so this depends on what you need to look at. So if you're looking at internal light spill, then there's only a couple of light softwares that will be able to look at internal spill and external spill with the combined effect, and they are Dilux Evo. So there's Dilux, Dilux Normal, and then there's Dilux Evo, which is the one that I showed you the images where you can see in 3D what's going on, which I think is quite useful, actually, especially for communicating the results to the project team as a whole. It's quite a handy software to use. And I think similarly, AGI32 is another software that's capable of this.
Great, thank you. Gabriel says, we often recommend switch off times. However, the client often says that those times are when people need the lighting. What do you recommend in this instance?
That is quite a tricky one, and it does seem to often conflict. So sometimes switching lighting off won't be a suitable option, really, because if we're going to switch the lighting off when the humans using the area need it, then there's kind of no point in having that lighting. So that's quite a difficult question, really. I think sometimes the switch off may not be so useful, but now with dimming regimes means that we can reduce the levels down. So in some areas, they're using dimming regimes of 50%, for example, maybe from, I don't know, 11 o'clock till midnight, and then they drop down again to maybe 25% output for the bigger period during the night. But whether they conflict and work with the requirements for bats, it isn't always the case. So that's a little bit of a tricky one, really, to answer.
Okay, thank you very much. Melanie says, that was a whistle-stop tour of the impacts of lighting. Would you explain what you mean by reduced output luminaries again, please? These were lighting columns where they were impacting upon a dark zone.
Yeah, okay. Yeah, I know it was a whistle-stop tour. I've added things into this presentation because of so many questions that have been asked, and it started to get a little bit long, so I have to try and be kind of quick. So with the reduced output luminaires, so what I mean by that is with LED, we can much easily specify basically cutting the output of the luminaire. So where we could use a dimming regime, for example, that would actually dim the luminaire down, say, to 50%. But what we can also do is ask the factory to limit the output to 50%. So we can easily calculate on that drawing, for example, we initially calculated the design so that it would be fully compliant with the council's requirements. And then we looked at reducing the levels in the areas that were sensitive. And we did this by reducing it down like 50% output of that luminaire, and that could be specified from the factory to be delivered to site as a limited output luminaire.
Thank you. Amy says, what are the consequences, in brackets legal, should a person remove planting or change lighting, which was conditioned as bat lighting mitigation? More to the point, is compliance enforced?
Sorry, I might have to read that question again. Where's that one? Hang on.
Where's it gone?
Amy Hall. Yep, I've got it.
Yeah.
Yeah, it's a tricky one. It's more of a planning question, really. Compliance being enforced is a bit of a difficult subject. I know in some instances now they're looking at maybe the management company actually doing checks to make sure the lighting is kept as it should be. So enforcing, for example, external lighting not being fitted to the backs of people's properties, that checks would be done by the maintenance company. Legally, it would be up to the council to enforce action. But if post-monitoring checks are done, that's another way of flagging up when an issue is in place, and then they could produce an enforcement action. So I think it comes down to, probably from our aspect, what we can do to improve this is encouraging the post-monitoring checks to be done so that we can ensure it stays as it should be.
Great, thank you. Are there any standard conditions that a local planning authority should use to ensure lighting is designed in accordance with the latest guidance?
I don't have a list of standard conditions, but it is actually something we're looking to include in the guidance we're working on at the moment. So that may be available in the not too far future.
Great, thank you. Is there a general buffer or distance you can recommend between light sources and commuting corridors, or does this largely depend on the type of lighting used?
Yeah, it depends on the type of lighting and the area that you're requiring to be lit, because the levels of lighting would then vary. So there's not really a standard answer to that one.
Okay. Andrew asks, are taller light columns better than shorter light columns for bats?
In some instances, yes, they are. So it does depend on what's happening and how that site's actually being used by bats. But what I would say from a lighting perspective is, by increasing the column heights, we can often direct the light sources more carefully and avoid too much light spill. So it can be beneficial. And definitely columns, sort of looking at kind of 5 meter columns, we can direct the light better sometimes and produce a better light level than with bollards, for example.
Perfect, thank you. Steph asks, is there a zonation map of dark areas of the UK based on the ones you were speaking about in your presentation?
No, there isn't, and I wish there was. It's very pick and mix. Some councils have plans for their areas that show what the environmental zones are and where dark areas are, and some don't. So it's a mixed bag on that one.
Okay, thank you. Tony asks, have you found that LPAs have changed the wording of their conditions since the guidance has been issued? Are there certain LPAs or parts of the country which are particularly up to speed?
I think that's a difficult one for me to answer, because I probably haven't dealt with all of the councils, and I think it's starting to get built into those conditions. I've seen a couple where it's been referencing the guidance, and I think that's only going to increase over time. So it's a good thing.
Okay, thank you. Tom asks, I assume floodlights are generally bad news for proposed dark zones. Is there any specific mitigation for floodlighting, for example, for sports pitches, in addition to lowering the column heights and creating barriers?
Not really any specific guidance. So again, sports lighting, the pitches really vary in how bright they need to be lit. It actually varies quite widely depending on the type of sport, the league that they're in, and all those kinds of things. Probably the best guidance is floodlighting, if it's downward directional and has shields, can be contained quite well. But you will need to think about quite a big buffer distance from a floodlight, because you're looking at 200 lux, for example, lit on the pitch. So it's probably going to have spill up to sort of, I don't know, 20 meters, 30 meters. It's going to be quite a lot of spill from that kind of installation, even with shielding and that kind of thing. So you need to probably think about barriers and fencing and other mitigation measures.
Perfect, thank you. We've done an extra 10 minutes. We still have 19 questions. Would you like to carry on? Or?
I think maybe best if you maybe email them to me.
Yes,
Yeah.
yeah, that would be great. Thank you very much.
Thank you.
Yeah, thank you everyone for joining us and for all of your questions. Yeah, I'll send them across to Bonnie, and Bonnie will get back to you as soon as she can. We will also be sending out a feedback survey shortly after the webinar, and we do welcome your feedback for future webinars. And thank you again, Bonnie, and thank you all for joining us, and we look forward to welcoming you to the next webinar.